Right now, you're experiencing something that doesn't exist. You feel it passing, slipping through your fingers like water. You plan for it, fear losing it, wish you had more of it. But according to the deepest laws of physics, the flow of time you're experiencing in this moment is no more real than a dream. Einstein knew it. Quantum physicists have proven it. And in about an hour, you'll understand why the present moment you think you're living in is the universe's most convincing magic trick. Let me show you what I mean. Take a breath and notice it. Feel the air entering your lungs. That breath is happening now, right? But what if I told you that now doesn't mean the same thing on Mars as it does on Earth? That the present moment you're experiencing has no universal twin anywhere else in the cosmos. The moment you think we're sharing as you listen to these words exists only in your mind, constructed from memory and expectation, assembled by neurons firing in patterns that create the illusion of a flowing river called time. The universe itself has no such river. At the quantum level, where reality is written in its most fundamental language, there is no variable for time, no equation that describes its flow. The past, present, and future don't line up in the neat sequence your brain insists they do. They exist all at once, like frames in a film that was never meant to be played. And the feeling you have right now, that sensation of time moving forward, carrying you from one moment to the next. That's your brain's story, a necessary fiction, an evolutionary tool that helped your ancestors survive, but tells you almost nothing about how the universe actually works. This isn't philosophy, it's physics, and it's about to change how you experience every moment of your life. In 1905, a patent clerk in Switzerland published a paper that would shatter humanity's understanding of reality. Albert Einstein wasn't trying to prove that time is an illusion. He was trying to solve a problem about light and motion. But the mathematics led him somewhere unexpected, somewhere so strange that even he struggled to accept its implications. The equations were clear. Time is relative. It flows at different rates depending on how fast you're moving and how strong the gravitational field around you is. This wasn't a small adjustment to Newtonian physics. It was a complete demolition of the common sense world. Time, Einstein realized, isn't the universal metronome we thought it was. There's no cosmic clock ticking away the same seconds for everyone. An astronaut traveling near the speed of light ages slower than someone on Earth. Not metaphorically, actually, measurably. Their cells divide more slowly. Their thoughts unfold at a different pace. When they return home, less time will have passed for them than for the people they left behind. We've tested this. Atomic clocks on jets flying around the world show measurable differences from identical clocks left on the ground. GPS satellites have to account for time dilation, or your navigation would be off by miles. Time literally passes faster at the top of a mountain than at sea level because gravity is slightly weaker there. These aren't tiny theoretical effects. They're real, confirmed by every experiment we've done. But here's what makes it even stranger. If time flows at different rates for different observers, then there's no universal now. The present moment isn't synchronized across the universe. When you look at the stars, you're seeing ancient light from events that happened years, centuries, or millennia ago. The star might not even exist anymore by the time its light reaches your eyes, but you're seeing it now, in your present moment. What does now even mean when it's different for everyone? Einstein struggled with this question for the rest of his life. In 1955, shortly before his death, he wrote to the widow of his lifelong friend Michel Besso, who had just passed away. The letter contained one of the most haunting sentences in the history of physics. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Only a stubbornly persistent illusion. Think about what that means. The man who revolutionized our understanding of space and time was telling us that the flow of time itself, the thing we experience more directly than almost anything else, doesn't really exist. It's a trick, a phantom, a story we tell ourselves. But if time isn't flowing, what are we actually experiencing? Imagine a DVD sitting on a shelf. The entire movie is there, beginning, middle, and end. Nothing about the disc itself is changing or flowing. The dramatic scenes, the character development, the emotional arc, it's all encoded into a static object. When you play it, you experience the story unfolding moment by moment. But that's just your perception moving through something that exists all at once. According to Einstein's relativity, the universe is like that DVD. Physicists call it the block universe, and it's one of the most philosophically unsettling ideas in all of science. In this view, past, present, and future all exist simultaneously in a four-dimensional structure called space-time. Your birth, your first day of school, this moment right now, your last breath. They're all equally real, all existing together in the block. Time isn't flowing. You're just moving through it, experiencing one slice after another, creating the illusion of passage. MIT physicist Max Tegmark describes it like this: reality is either a three-dimensional place where stuff happens over time, or it's a four-dimensional place where nothing happens. If it's the second picture, then change is an illusion. There's nothing changing. It's all just there. Life is like a movie, and space-time is like the DVD. Nothing about the DVD is changing, even though there's drama unfolding when you watch it. This isn't some fringe theory. It's a mainstream interpretation of relativity. The mathematics works. The predictions match observations, and it solves certain paradoxes that plague other views of time. But it creates new problems, deeper ones, questions that cut right to the heart of what it means to be human. If all moments exist simultaneously, is the future already determined? When you make a choice to keep listening to this video, or to pause it, to call a friend, or let the thought fade, is that choice real? Or is it just you experiencing a predetermined point in the space-time block? Are you discovering your future or creating it? The block universe doesn't give easy answers. Some physicists argue that free will is compatible with a static space-time. Others say it's an illusion too, another trick your brain plays to make sense of a reality that doesn't actually contain agency or choice. What everyone agrees on is this: the block universe is what the math tells us, and if the math is right, then everything you think of as past is still happening. Everyone you've lost still exists in their moment. Every mistake you regret is frozen in the block, as permanent and unchanging as the event where you tried to fix it. Nothing is gone. Nothing is yet to come. It's all here, all now, in a way that makes now meaningless. Take a moment to let that settle. If you're feeling a bit unmoored, you're in good company. Philosophers have been wrestling with the block universe for over a century. Some find it liberating. Your mistakes aren't really in the past because the past isn't really gone. Others find it suffocating. Your future isn't really open because the future already exists. But the emotional reaction doesn't change the physics, and the physics gets stranger. If relativity made time weird, quantum mechanics made it disappear entirely. In the early 20th century, physicists started probing the behavior of atoms and subatomic particles, expecting to find tiny versions of the classical world. What they found instead was a reality so bizarre that even the people who discovered it couldn't quite believe it. Particles don't have definite positions until you measure them. They exist in multiple states simultaneously. They influence each other instantly across vast distances. And when you try to write down the fundamental equations that govern quantum reality, something shocking happens. Time vanishes. In the 1960s, physicists John Wheeler and Wheeler-DeWitt attempted to merge quantum mechanics with general relativity. They wanted a theory of quantum gravity, a set of equations that could describe the universe at its most fundamental level. What they got was the Wheeler-DeWitt equation, and its most disturbing feature is this: there's no time variable in it. The equation describes a universe that is completely static, frozen, timeless. All of history, every event that has ever happened or ever will happen, exists in a single, unchanging quantum state. This is the frozen universe paradox. At the deepest level, according to our best attempt at a unified theory, nothing moves, nothing changes, nothing happens. The entire cosmos, from the Big Bang to the heat death of the universe, is one eternal moment. If that's true, where does time come from? How do we explain the undeniable fact that we experience change, motion, causation? If the fundamental equations have no time variable, why does it feel like time is the most real thing there is? Some physicists think the answer lies in a concept called emergence. Just as wetness emerges from countless H2O molecules, even though no individual water molecule is wet, time might emerge from quantum interactions, even though the quantum level itself is timeless. Theoretical physicist Carlo Rovelli has spent decades developing this idea. He argues that time is a side effect of our ignorance. We don't see the full quantum state of the universe, so we experience a partial, macroscopic view where time appears to flow. At the quantum level, Rovelli says, there are no things, only events. What looks like a solid object is really a pattern of events happening so fast we can't register them. A stone isn't a thing that persists through time. It's a process. A dance of quantum interactions unfolding at a rate our senses can't detect. And what we call time is just the relationship between these events, not some external river they're flowing through. The absence of time from the fundamental equations doesn't mean nothing changes. It means elementary processes can't be ordered along a common succession of instants. Every quantum event dances independently with its neighbors, following its own rhythm. Time is born from this dance, emerging from the relationships between events rather than existing as a backdrop for them. It's a beautiful idea, but it raises more questions than it answers. If time emerges from quantum relationships, does it emerge gradually? Is there a level of reality where time is partially real, flickering in and out of existence? And what about our experience? When does the timeless quantum realm become the flowing time we perceive? The answer might be even stranger than the question. In the 1980s, two physicists named Don Page and William Wooters proposed a radical solution to the frozen universe paradox. They suggested that time doesn't exist for the universe as a whole, but it does exist for observers inside the universe. How? Through quantum entanglement. Entanglement is one of the weirdest phenomena in physics. When two particles become entangled, they remain connected no matter how far apart they are. Measure one, and you instantly know something about the other, even if it's on the other side of the galaxy. Einstein called it spooky action at a distance and suspected it might reveal a flaw in quantum mechanics. But experiments have confirmed it repeatedly. Entanglement is real. Page and Wouters realized that entanglement could solve the time problem. If you're an observer inside the universe, entangled with the systems around you, you'll experience time passing, even though the universe as a whole remains in a timeless state. Time emerges from the relationships between entangled systems. It's not a fundamental feature of reality. It's a side effect of quantum connections. For decades, this was just a theoretical idea. Then, in 2013, researchers in Turin, Italy, put it to the test. They created a simple quantum system. 2 entangled photons, one acting as a clock, and the other as the system being observed. From an external perspective, the entire setup was in a static, timeless quantum state. But from the perspective of the clock photon, the other photon appeared to evolve through time. The experiment worked. Time is an emergent phenomenon for internal observers, but absent for external ones. If you're inside the universe, entangled with everything around you, you experience time. If you could somehow step outside and view the universe as a whole, you'd see a timeless, static structure. This has profound implications. It means time isn't woven into the fabric of reality. It's something that arises from relationships, from connections, from the fact that we're part of the universe rather than outside it. Your experience of time passing right now, the sense that this moment is flowing into the next, is a product of your quantum entanglement with the world around you. And here's the twist. Different observers, entangled in different ways, experience time differently. Time isn't just relative in the sense Einstein meant. It's personal. It depends on your relationships with the systems around you. There's no universal timeline threading through reality because time itself is an emergent, observer-dependent phenomenon. You might be thinking, this is too abstract, too removed from everyday experience. But consider this. Every memory you have, every plan you make, every moment of consciousness, all of it depends on your brain being entangled with itself. Different regions communicating through quantum correlations faster than classical signals could travel. Your sense of self, of continuity, of having a past and a future, it all emerges from the same quantum relationships that create time itself. You're not just experiencing time. You're generating it through the act of being entangled with the universe. And that raises a question we're only beginning to explore. Even if time is an emergent illusion, there's still something that needs explaining. Why does time seem to flow in one direction? You remember the past, but not the future. Eggs break, but don't spontaneously reassemble. Coffee and cream mix, but never unmix. There's an asymmetry to time, an arrow pointing from past to future, and it seems deeply woven into the fabric of reality. The answer has to do with entropy. In the mid-19th century, physicists studying heat engines discovered a curious law. In any isolated system, disorder always increases. Heat flows from hot to cold, never the reverse. Organized structures tend to break down into chaos. This is the second law of thermodynamics, and it's the only fundamental law of physics that gives time a direction. Entropy is a measure of disorder, of how many different microscopic arrangements could produce the same macroscopic state. A cup of hot coffee has low entropy. The heat energy is concentrated in one place. When the coffee cools and its heat spreads through the room, entropy increases. There are many more ways for the energy to be spread out than concentrated, so the spreading is vastly more probable than the reverse. This is why we see time flowing forward. We're observing entropy increasing, systems moving from order to disorder. And because our brains are part of this process, our memories form by creating ordered patterns that will eventually decay, we experience time as having a direction. The arrow of time is really the arrow of entropy. But here's the puzzle. The fundamental laws of physics are time reversible. If you filmed a collision between two particles and played it backward, you couldn't tell which direction was which. The microscopic laws don't distinguish between past and future. So why does the macroscopic world have such a strong directional arrow? The answer seems to be in the initial conditions of the universe. The Big Bang created a state of incredibly low entropy. Everything compressed, organized, uniform. Since then, entropy has been increasing, and it will continue to increase until the universe reaches maximum disorder, a state called heat death, where nothing interesting can happen anymore because there's no order left to break down. We live in the middle of this process, in a temporary pocket of increasing entropy. And that's why we remember the past, but not the future. Memory formation requires creating ordered structures in your brain, which means locally decreasing entropy. But the second law says total entropy must increase, so the price of forming memories is generating even more disorder elsewhere. The direction of entropy increase is the direction we call future, and it's the direction in which cause precedes effect. But does this mean the arrow of time is objective? Not quite. Carlo Rovelli argues that the arrow is a consequence of our perspective. We're macroscopic creatures who can't track the detailed microscopic state of systems. We see coarse-grained averages, and at that level, entropy appears to increase. But if we could see the full quantum state, the distinction between past and future would dissolve. Time's arrow would be revealed as another emergent feature, another consequence of our limited viewpoint. So the flow of time, the direction of time, and even the existence of time all seem to be products of perspective, of being inside the universe rather than outside it, of being entangled with systems we can't fully observe. Time isn't a river carrying us forward. It's a map we draw to navigate a reality that doesn't actually contain past, present, or future at the fundamental level. And your brain is the cartographer. Right now, you're experiencing what you probably think of as the present moment. It feels immediate, direct, unmediated. This is now. But neuroscience reveals something unsettling. The now you're experiencing is a construction, assembled by your brain from pieces that arrived at different times and processed at different speeds. Light from this screen hits your retinas and triggers electrical signals that travel to your visual cortex. Sound waves from your environment reach your ears and create different signals that take a different path to your auditory cortex. If you're touching something, tactile information travels along yet another pathway. All of these signals arrive at different times, taking different routes through your nervous system. Your brain has to solve a binding problem: how to combine all these different streams of information into a unified experience of a single present moment. The solution is to wait. Your brain holds sensory data for a fraction of a second, aligning everything so it can be presented to consciousness as a coherent now. What you experience as the present moment is actually a highlight reel of the very recent past, carefully edited and synchronized by neural networks. This explains why time perception is so malleable. During a car accident, people often report that time seemed to slow down. They remember details with unusual clarity, as if the moment stretched out. What's actually happening is that your brain, flooded with stress hormones, records more information than usual. When you recall the event, all that extra data makes it feel like the moment lasted longer than it did. The stopped clock illusion demonstrates this even more clearly. Next time you glance at a clock, watch the second hand. The first tick will seem to last longer than the others. This happens because your brain, filling in the gap during the eye movement, retrospectively extends the moment to create continuity. You never actually experience the gap. Your consciousness is edited to remove it, making the flow of time feel smooth even though it's choppy at the neural level. Time perception changes with age too. Children experience time as passing slowly. Years feel long. A summer vacation stretches endlessly. Adults experience time speeding up. Years fly by. Decades blur together. This isn't because time itself changes. It's because your brain processes novelty differently than familiarity. When everything is new, your brain encodes more memories, making periods feel longer in retrospect. When life becomes routine, fewer distinct memories form, and time seems to accelerate. There's also psychological time, distinct from clock time. Clock time is functional. You use it to schedule meetings, catch trains, plan your day. Psychological time is the mental habit of dwelling in past regrets or future anxieties. You replay conversations that already happened, imagining different outcomes. You rehearse scenarios that haven't occurred, preparing for possibilities that may never arrive. This is the illusion of psychological time, and it's one of the greatest sources of human suffering. When you're fully present, absorbed in music, lost in creative work, deep in conversation, psychological time disappears. Athletes call this the zone. Psychologists call it flow. In these states, the sense of past and future dissolves. There's only this action, this note, this moment. Time doesn't seem to pass because you're not constructing it from memory and anticipation. You're just here. These experiences reveal something crucial. The flow of time is optional. It depends on your mental state, on where your attention is directed, on whether you're generating the story of past to future or simply existing in unnarrated awareness. The feeling of time passing isn't constant or inevitable. It's a mode of consciousness, and there are other modes. But even in flow states, even in moments of timelessness, something is happening. Neurons are firing. Neurotransmitters are binding to receptors. Energy is being used. So while the experience of time may be constructed, the processes underlying that experience are real. The question becomes, are those processes happening in time, or are they the thing that generates time? In ordinary language, we divide time into three parts: past, present, and future. We think of the past as gone, the future as yet to come, and the present as the razor-thin edge between them where reality actually happens. This feels so obvious that questioning it seems absurd. But according to physics, this picture is completely wrong. Einstein's theory of relativity denies any absolute significance to the present moment. Simultaneity, whether two events happen at the same time, depends on the observer's motion. If you're standing still and I'm moving at high speed, events that are simultaneous for you occur at different times for me. There's no universal now that everyone shares. Rovelli makes this concrete with an example. When you look at Proxima Centauri, the nearest star to our solar system, you're seeing light that left the star 4 years ago. You're seeing what was on that star 4 years in the past. But there's no special moment on Proxima Centauri that corresponds to now on Earth. The idea of a present moment synchronized across space makes no sense in relativity. What we call the present is observer-dependent. It's a slice through space-time determined by your reference frame, your state of motion, your position in the gravitational field. Move to a different location or speed, and the slice shifts. Events that haven't happened yet from one perspective have already occurred from another. This has a strange consequence. The present moment, as a universal feature of reality, doesn't exist. What exists is the block universe, the four-dimensional structure where all events are equally real. Your sense of being in the present is a product of consciousness, of memory comparing the current brain state to stored past states and constructing a narrative of flow. Philosopher Hugh Price argues that the three properties we associate with time, a special present moment, a flow from past to future, and an absolute direction, come from our mental states, not from the physical world. Physics gives us the block universe, where time is just another dimension, like space. Our brains give us the illusion of flowing time because that's useful for survival. We don't actually observe time passing. We observe that later states of the world differ from earlier states we remember. The fact that we remember the past rather than the future is an observation about the asymmetry of time, not about time flowing. And that asymmetry, as we've seen, is really about entropy and the direction of increasing disorder. So the present moment you're experiencing right now, this feeling of being here in this instant, while the past recedes and the future approaches, is a story, a useful fiction, a way your brain organizes sensory data and memory to help you navigate reality. But it's not what's actually happening at the fundamental level. What's actually happening is far stranger and far more still. If time is an illusion, what are we actually experiencing? One way to approach this question is to look at states where the normal sense of time dissolves. Meditation offers a window into this. In deep meditative states, practitioners report that the sense of past and future fades. Thoughts slow down or stop entirely. The narrative voice that usually chatters about yesterday and tomorrow goes quiet. What remains is awareness itself, without the temporal structure we normally impose on it. This isn't mysticism. Brain imaging studies show measurable changes during meditation. The default mode network, the brain regions associated with self-referential thinking and mental time travel, becomes less active. The posterior cingulate cortex, which plays a role in distinguishing self from environment and past from present, shows reduced connectivity. The experience of timelessness corresponds to specific neural patterns. But meditation isn't the only path to this state. Athletes in flow describe a similar phenomenon. A basketball player in the zone doesn't think about the last shot or the next defender. There's only this moment, this movement, this perfect arc of the ball. Time seems to slow down not because it actually does, but because the mental construction of time has stopped. People in extreme situations report this too. Soldiers in combat, drivers in accidents, climbers whose ropes snap. In these moments, the brain shifts into a different mode. Analytical thinking shuts down. Time perception warps. Some describe it as everything moving in slow motion. Others say time stopped entirely. What they're describing is the cessation of the brain's normal time construction process. These experiences suggest that the flow of time isn't a passive perception like seeing color or hearing sound. It's an active construction, something your brain does rather than something it receives. And like any constructed experience, it can be modified, suspended, or eliminated entirely under the right conditions. The implications are profound. If the flow of time is something your brain generates, then the distinction between past, present, and future isn't a feature of reality. It's a feature of consciousness. And consciousness, for all its mystery, is a biological process subject to the same physical laws as everything else. Which brings us back to the fundamental question. If physics says time doesn't exist, and neuroscience says our experience of time is constructed, what's actually going on? Are we living in a timeless universe, hallucinating change? Or is there something about consciousness that makes time real in a way that physics can't capture? The answer might require us to rethink what we mean by real. You've been listening for a while now. Maybe you've paused to think about what you're hearing. Maybe you felt a bit disoriented, like the ground beneath moments of resistance, your mind pushing back against ideas that seem to contradict everything you know. That resistance is natural. Your brain evolved to treat time as real, because treating it as real kept your ancestors alive. The gazelle that could predict where the lion would be in 3 seconds survived. The one that couldn't became lunch. But survival and truth aren't the same thing. Your brain is a prediction machine, constantly building models of reality based on incomplete information. One of those models is time, a framework for organizing cause and effect, for linking memories to expectations, for navigating a world of change. The model works beautifully for everyday life. It breaks down completely when you zoom into the quantum level or zoom out to the cosmic scale. So where does this leave us? If time is an illusion, should we stop planning for the future? Stop learning from the past? Obviously not. Clock time, the practical use of time for scheduling and coordination, remains useful. What changes is your relationship to psychological time. That mental habit of living in memory and anticipation rather than present awareness. Buddhist philosophy has been pointing to this distinction for 25 centuries. The Buddha taught that attachment to thoughts about past or future creates suffering, not because the past and future don't matter practically, but because identifying with those thoughts pulls consciousness out of the only moment that actually exists. This one. The present isn't a thin slice between past and future. It's the entire arena of experience, the only place where life actually happens. Modern psychology has rediscovered this in the concept of flow. When you're fully absorbed in an activity, time doesn't disappear because it stops flowing. It disappears because you stop constructing it. The chattering narrative voice goes quiet. The distinction between self and world blurs. There's just this action, this awareness, this moment of being. These aren't contradictory views of time, the physics perspective and the meditative perspective. They're pointing to the same truth from different angles. Time, as a flowing river carrying us from past to future, is a mental construction. Reality at the fundamental level is timeless, or perhaps more accurately, all at once. What we call time emerges from our perspective as observers inside the system, entangled with everything around us, experiencing one slice of the block universe after another. But here's what makes this profound rather than merely interesting. Recognizing the illusory nature of time doesn't diminish your experience. It enriches it. When you understand that the present moment isn't a fleeting instant, but the entire structure of your experience, it becomes possible to inhabit it more fully. The past isn't a place you can return to. It exists only as patterns in your neurons right now. The future isn't a destination you're heading toward. It exists only as simulations your brain runs in this moment. Everything is here. Everything is now. Not in a mystical sense, but in a physical one. The block universe means your entire timeline exists, and the part of it you're experiencing right now is as real as any other part. There's nothing more real waiting in the future. Nothing more authentic that existed in the past. This moment contains the totality of your experience, because this moment is all there ever is. Take a breath and notice what that feels like. Not to think about it, but to feel it. The difference between knowing intellectually that time is an illusion and experiencing the timeless present is the difference between reading about swimming and jumping into water. One is information, the other is transformation. If time is an illusion, what does that mean for your identity? You think of yourself as a continuous being with a history stretching back to childhood and a future extending who knows how far. But that continuity is another construction, another story your brain tells by linking present experience to stored memories. Memory isn't a recording device. Neuroscience has shattered that metaphor completely. When you remember an event, you're not retrieving a stored file. You're reconstructing it from fragments, filling in gaps with expectations and current context. Every time you recall a memory, you slightly change it. The memory you have of your 10th birthday isn't the experience itself, and it isn't even the memory you had of it last year. It's a current reconstruction, modified by everything that's happened since. This means your past doesn't exist as a fixed archive somewhere in your brain. It exists as present neural activity, patterns firing right now, generating a sense of history that feels continuous, but is actually being constantly rewritten. The person you were 10 years ago isn't someone you used to be. It's a story you're telling now about a pattern that once existed. And your future? It's another story, assembled from memory fragments and current concerns. When you imagine next week or next year, you're not accessing some timeline that already exists. You're creating a simulation, a narrative built from pieces of the past and present, projected onto the screen of consciousness as if it were a preview of something yet to come. What you call you is a narrative constructed moment by moment from these materials. There's no essence of self that persists unchanged through time, because time itself isn't what we think it is. The self is more like a wave than a particle, a pattern of energy moving through matter, creating the appearance of continuity, while the underlying substance constantly changes. This isn't nihilistic, it's liberating. If your identity is a story rather than a fixed thing, then the story can change. The person you think you've always been is just one interpretation of the patterns, one way of organizing the data. Different stories are possible. Different selves can emerge from the same history. Consider someone who's experienced trauma. Traditional therapy often involves revisiting the past, processing what happened, integrating it into a coherent narrative. But what if the past isn't a thing that happened? What if it's a present construction that can be reconstructed differently? This isn't about denying events or bypassing necessary healing. It's about recognizing that the meaning of those events, the way they're woven into identity, is flexible in ways we haven't fully appreciated. The Buddhist concept of anatta, no self, makes more sense in this light. The Buddha taught that what we call the self is really a collection of processes, not a thing. You're not a noun, but a verb, not a being, but a becoming. And if that's true, then clinging to a fixed sense of self creates suffering because you're trying to hold on to something that never existed in the first place. Modern neuroscience agrees. The brain has no central headquarters where a unified self resides. Consciousness emerges from distributed networks, different regions contributing different aspects of experience. The feeling of being a unified self is generated by these networks talking to each other, creating the illusion of a singular observer. But there's no little person inside your head watching the show. There's just the show, generating itself moment by moment. This is where physics and contemplative practice converge. Time is an emergent property of quantum entanglement. Self is an emergent property of neural activity. Both feel absolutely real from the inside. Both dissolve when you look closely at their foundations. And both, when seen clearly, reveal that reality is far more fluid and participatory than it appears. You're not a thing moving through time. You're a pattern of information constantly refreshing itself, creating the appearance of continuity through the same process that creates the appearance of time. Every moment, you're new. Every moment, the universe is reconstructing itself. And the version of you reading these words right now has never existed before and will never exist again. That's not a loss. That's the nature of reality. And once you see it, you can't unsee it. We've covered a lot of ground. Einstein's relativity revealing the time is observer-dependent. Quantum mechanics suggesting time isn't fundamental at all. The block universe showing that past, present, and future all exist simultaneously. Entropy giving time its arrow. The brain constructing the flow of time from memory and prediction. But there's one more piece to this puzzle, and it might be the most important. If time is an illusion, how should you live? The question sounds abstract, but it has immediate practical implications. Should you stop planning? Stop learning from mistakes? Stop setting goals? Obviously not. Clock time remains useful for coordination and navigation, but psychological time? The mental habit of living in past regrets or future anxieties becomes optional once you recognize its constructed nature. The key is understanding the difference between using time and being used by it. You can use clock time to plan a meeting without your mind living in that future meeting right now. You can learn from past experiences without replaying them endlessly, identifying with emotions that belong to a previous configuration of neural patterns. This is what mindfulness practice has always pointed toward. Not the elimination of thought or the suppression of memory, but the recognition that thoughts and memories are present experiences, not portals to other times. When you remember yesterday, that memory is happening now. When you plan for tomorrow, that planning is happening now. Everything you experience, by definition, happens in this moment. But this moment doesn't mean a fleeting instant. The present isn't a razor's edge between past and future. It's the entire field of awareness, the only place where experience actually occurs. Past and future exist within it as neural patterns, as thoughts, as simulations. But they don't exist as places you can actually go, because time isn't a dimension you can travel through. It's a map you draw to organize change. Athletes understand this intuitively. In peak performance, there's no past or future, only this shot, this movement, this breath. Musicians know it too. In flow, there's no separation between player and music, no gap between intention and action. Surfers riding waves, dancers lost in rhythm, painters absorbed in color, they're all accessing the same state, consciousness without the temporal narrative. And it's available to you right now, not through some special technique or years of practice, but simply by noticing what's actually happening. Your experience is always present, always now. The sense of being carried along by time is a thought, and that thought is happening now. The feeling of waiting for some future moment to be happy is happening now. The belief that the present is somehow less real than some imagined future or remembered past is happening now. Nothing is elsewhere. Nothing is else when. Everything you've ever experienced and everything you will ever experience happens in this eternal now. Not because time has stopped, but because time was never what we thought it was. The block universe doesn't trap you in a predetermined fate. It reveals that all moments are equally real, equally vivid, equally here. Your life isn't a journey from birth to death. It's a four-dimensional structure, existing all at once. And the part of it you're experiencing right now is the only part you'll ever experience, because now is all there is. This isn't philosophy anymore. It's physics translated into lived experience. The timeless universe isn't some abstract realm separate from your daily life. It's the actual nature of the reality you're already living in. You've just been interpreting it through the filter of time, adding the illusion of flow to what is fundamentally still. But you don't have to take my word for it. You can test this directly. Next time you find yourself anxious about the future or ruminating about the past, pause and ask, where is this happening? Is the future here right now? Is the past present? Or is there just this moment, this breath, this awareness, these sounds and sensations, with thoughts about other times arising within it? The answer reveals itself immediately. And once you see it clearly, the question isn't whether time is real. The question is, why did you ever think it was? We've explored the physics that reveals time as an illusion, from Einstein's relativity to quantum mechanics to the Wheeler-DeWitt equation. We've seen how entropy creates time's arrow, and how the brain constructs the flow of time from memory and expectation. We've touched on the block universe, on emergence, on the observer-dependent nature of now. But there's more to this story, much more. Because if time is an illusion, what about space? If the flow of time emerges from quantum entanglement, what does that say about consciousness? And if the entire structure of past, present, and future is a construction, what's actually real? In the next part of this exploration, we're going deeper. We'll look at how space itself might be emergent, arising from information relationships rather than being fundamental. We'll explore what the Wheeler-DeWitt equation really means for the nature of reality, and whether the frozen universe it describes is a bug or a feature. We'll examine how information theory is revolutionizing physics, and why some scientists think information, not matter or energy, is the fundamental substrate of existence. We'll also venture into more speculative territory: quantum consciousness theories, the relationship between observation and reality, and what it might mean if awareness itself is woven into the fabric of the cosmos. Some of these ideas remain unproven, some are controversial, but all of them follow logically from what we've already covered, extending the implications of time's illusory nature into realms that challenge everything we think we know about mind, matter, and reality itself. Because here's what we haven't fully addressed yet. If time is an illusion created by observers inside the universe, what does that say about the observers themselves? Are we fundamental features of reality, or are we emergent too? And if consciousness is what generates the experience of time through quantum entanglement, then understanding time means understanding awareness itself, what it is, where it comes from, and what role it plays in shaping the universe we experience. These questions don't wait at the threshold of the next mystery. They demand answers. Here's something that will shift your entire framework. Space might not be real either. You've spent your whole life assuming that space is the stage, the three-dimensional container where events unfold. Objects exist at specific locations. You move through space to get from one place to another. Distance is fundamental. This seems obvious, undeniable, woven into the fabric of experience itself. But what if distance isn't measuring separation through space? What if it's measuring something else entirely? Something far stranger. Recent work in quantum information theory suggests that what we call distance might actually be a measure of how much information we need to specify the relationship between two quantum systems. Space, in this view, doesn't exist independently. It emerges from patterns of quantum entanglement between particles. Think about what this means. When you say two objects are far apart, you might really be saying they share very little quantum information. When things are close together, they're highly entangled, deeply connected through quantum correlations. Distance becomes a measure of information connectivity rather than a fundamental property of reality. Physicist Eric Verlinde has taken this further, showing that Einstein's equations of general relativity, which describe gravity as the curvature of space-time, can be derived from thermodynamic principles applied to quantum information. Gravity itself might be an emergent phenomenon arising from information relationships. If gravity emerges from information, and space-time is the arena where gravity operates, then space-time itself must be emergent from deeper information structures. The stage isn't fundamental. The stage is constructed from something more basic, from quantum information, and the patterns of entanglement that connect all things. This represents a complete inversion of our usual picture. We normally think information exists in space, but the evidence increasingly points to space existing in information. Or more accurately, space as we experience it is what information relationships look like from the inside. Your body appears to occupy a specific location in space. But at the quantum level, the particles that compose you are entangled with particles throughout the universe. The boundaries you perceive, where you end and the rest of the universe begins, might be artifacts of limited information access rather than fundamental divisions in reality. Some theories go even further. Loop quantum gravity proposes that spacetime itself is quantized, made of discrete, indivisible units. At scales smaller than the Planck length, about 10 to the negative 35th meters, the smooth continuum of space breaks down into a granular structure, a quantum foam where the usual notions of distance and location cease to have meaning. At this scale, asking where something is becomes as meaningless as asking what time it is in the Wheeler-DeWitt universe. Location, like duration, might be emergent, appearing only when we zoom out to larger scales where quantum effects average into classical behavior. This has profound implications for consciousness. If both space and time are emergent rather than fundamental, then the feeling of being located at a specific point in space-time, the sense of being here, now, represents a double illusion. You're not really located anywhere, and it's not really any particular time. Those are constructions arising from how information is organized and accessed. What remains when space and time dissolve? Information and relationships, patterns of correlation, quantum entanglement connecting systems across scales and configurations, and somehow, within this web of information, conscious observers emerge who experience themselves as localized entities moving through space-time. But you're not moving through space-time. You're a pattern of information that includes the experience of space-time as part of its structure. The observer and the observed, the map and the territory, aren't separate. They're aspects of the same informational reality, temporarily organized in a way that creates the illusion of separation. The Wheeler-DeWitt equation presents us with perhaps the most unsettling implication of quantum gravity. At the most fundamental level, the universe might be completely static. When John Wheeler and Wheeler-DeWitt applied quantum mechanics to the universe as a whole, they derived an equation that describes the quantum state of the entire cosmos. The equation's most striking feature? Time vanishes completely. There's no time variable, no evolution, no change. The universe exists in a single, unchanging quantum state encompassing everything that ever was or ever will be. This is the frozen universe paradox. If the fundamental description of reality has no time, how do we explain the dynamic, evolving cosmos we observe? How do we reconcile a timeless universe with our experience of change, growth, decay, and transformation? The answer lies in recognizing that the timeless description applies to the universe viewed from outside, from what's sometimes called a God's eye perspective. But we're not outside observers. We're subsystems within the universe. And from our internal perspective, time emerges through our quantum entanglement with other subsystems. This is precisely what the Page-Wooter's mechanism describes. The universe as a whole exists in a static, time-independent quantum state. But observers within the universe perceive time passing because they're entangled with other parts of the universe that can serve as clocks, systems whose states change in ways that can be used to mark temporal progression. Your experience of time isn't the universe evolving. It's your entanglement with other quantum systems creating correlations that you interpret as temporal flow. From the external perspective, nothing is changing. From your internal perspective, embedded within the quantum web, time appears to pass because your state is correlated with the states of other systems in ways that follow a consistent pattern. Consider what this means for the question of change. The Wheeler-DeWitt equation doesn't imply that everything is frozen and motionless. It means that change is ubiquitous. But elementary processes cannot be ordered along a common time axis. At the quantum scale, every process dances to its own rhythm, following its own internal clock, without reference to a universal timeline. Carlo Rovelli describes this beautifully. At the extremely small scale of quantum spacetime, the dance of nature doesn't develop to the rhythm kept by a single orchestral conductor. Every process dances independently with its neighbors, following its own timing. The passing of time is intrinsic to the world, born from the world itself rather than imposed from outside. From this perspective, the frozen universe isn't a bug. It's a feature. The timeless quantum state contains all possible temporal orderings, all possible ways events can be sequenced. Observers within the universe experience one particular ordering based on their entanglement relationships, but the fundamental reality includes all orderings simultaneously. This resolves the paradox. The universe is both frozen and dynamic, frozen from the external perspective, dynamic from any internal perspective. Time doesn't exist out there in the universe. Time is the relationship between your state and the states of other systems you're entangled with. Every moment of your experience represents a particular configuration of quantum correlations, a specific way your internal state relates to the states of systems around you. What you call the present moment is just the current correlation pattern. What you call past and future are other correlation patterns, equally real in the timeless quantum state, but inaccessible from your current configuration. The block universe makes sense now. It's not that all moments in time exist simultaneously in some mysterious way. It's that the timeless quantum state contains all correlation patterns, and observers experience different patterns as different moments. The DVD analogy is apt. The information is all there, encoded in the static quantum state, and consciousness is what plays it back. creating the experience of movement through time. If space and time are emergent, what's left? What's the fundamental substrate from which everything else arises? The answer, according to a growing number of physicists, is information. Not information in the everyday sense, not knowledge or data stored in computers or books, but physical information, the fundamental patterns, correlations, and relationships that constitute reality at its deepest level. Quantum information, described mathematically through states, operators, and entanglement measures. This information-theoretic view of physics represents a radical departure from traditional materialism. For centuries, we've thought of reality as fundamentally made of matter and energy, with information being something derived, a description of matter's configuration. But the new picture inverts this. Information is fundamental, and matter and energy are emergent patterns in the informational structure. John Wheeler, one of the pioneers of this view, coined the phrase "it from bit," suggesting that every it, every particle, every field, every aspect of physical reality derives from binary information, from yes or no quantum alternatives. In Wheeler's vision, physics is ultimately about information processing, and the universe is a vast quantum computer calculating itself into existence. Recent work has made this concrete. The holographic principle, arising from black hole physics, suggests that all the information contained in a volume of space can be encoded on its boundary. Like a hologram where three-dimensional information is stored on a two-dimensional surface. This implies that spatial volume isn't fundamental, but rather emerges from information encoded on boundaries. Leonard Susskind and others have shown that quantum entanglement, the correlations between quantum systems, creates the geometry of space-time. Where there's strong entanglement, space is smooth and connected. Where entanglement is weak or absent, space becomes disconnected or doesn't exist at all. The structure of space literally emerges from the pattern of quantum information relationships. This has been tested through the E equals EPR conjecture, which proposes that quantum entanglement between particles, EPR, after Einstein-Podolsky-Rosen, creates wormhole-like connections in space-time geometry, ER, after Einstein-Rosen bridges. Entanglement and geometry are two descriptions of the same underlying informational reality. What does this mean for you? Composed of approximately 10 to the 28th atoms, each participating in countless quantum correlations. You're not a collection of particles existing in space. You're a pattern of quantum information, a configuration of correlations within the universal information structure. Your body, your brain, your thoughts, all are informational patterns, temporary organizations of quantum correlations that create the experience of being a localized, persisting entity. Consciousness, from this view, might be what information processing feels like from the inside. When information is organized in sufficiently complex patterns, patterns that model themselves, that create internal representations of their own states and their relationships to other systems, subjective experience emerges. You're not just processing information, you are information that has become aware of itself. This explains why consciousness seems so mysterious when viewed from a materialist perspective. If you assume the fundamental reality is unconscious matter, consciousness becomes an inexplicable add-on, something that emerges from matter in ways we can't comprehend. But if information is fundamental, and certain patterns of information naturally include subjective experience as an intrinsic aspect of their structure, consciousness isn't mysterious at all. It's simply what certain informational configurations are. The hard problem of consciousness, Why physical processes should feel like anything from the inside dissolves when you recognize that the question assumes a false premise. Physical processes don't give rise to consciousness. Consciousness is what certain physical processes are, viewed from the internal perspective. The internal and external views aren't describing different things connected by some mysterious bridge. They're describing the same informational reality from different vantage points. This also resolves questions about the relationship between observation and reality in quantum mechanics. Why does measurement collapse superposition states? Because measurement is an information exchange between systems. When a quantum system becomes entangled with a measuring apparatus, information flows, correlations form, and what was indefinite becomes definite through the establishment of these correlations. The collapse isn't caused by consciousness doing something magical to matter. The collapse is the formation of new information relationships. Now we arrive at the territory where physics meets philosophy, where the equations encounter the subjective, where the third-person description of the universe confronts the first-person fact of awareness. If time emerges from quantum entanglement and consciousness involves quantum processes in the brain, then understanding time requires understanding awareness. The observer isn't separate from the observed. The act of observation participates in creating the reality being observed. This isn't mysticism. It's what quantum mechanics has been telling us since its inception. The Copenhagen interpretation, despite its problems, correctly identified something fundamental. The observer plays a role in determining outcomes. Measurement doesn't just reveal pre-existing properties. It participates in actualizing specific possibilities from the quantum superposition. But what constitutes an observer? Does it require consciousness, or will any physical system that records information suffice? This question has divided physicists for decades. Some interpretations, like decoherence theory, suggest that any interaction with the environment, any exchange of information, effectively causes the collapse of superposition states. Consciousness isn't special. Any sufficiently complex system that records information can serve as an observer. Other interpretations maintain that consciousness plays an irreducible role. The physicist Eugene Wigner famously argued that only conscious observation can collapse the wave function, leading to the puzzle of Wigner's friend. If quantum mechanics requires consciousness for collapse, and a conscious observer is themselves a quantum system, who collapses their wave function? The information-theoretic view offers a middle path. Observation is fundamentally about information exchange and the formation of correlations. Consciousness is special not because it violates physics, but because conscious observers are systems with particularly rich internal models of their environment. When you observe something, you're not just recording information. You're integrating that information into a complex web of existing knowledge, memory, and predictive models. This integration creates what we experience as the present moment, the seamless synthesis of sensory input, memory, expectation, and awareness into a unified experiential field. Time, from this perspective, isn't something consciousness observes. Time is how consciousness structures information, how it organizes the flow of correlations into a coherent narrative of past, present, and future. Recent experiments have explored the boundaries of quantum consciousness. Studies of quantum effects in biological systems, photosynthesis, bird navigation, enzymatic reactions, show that quantum coherence can persist in warm, wet environments far longer than previously thought possible. This raises the possibility that the brain might exploit quantum effects in ways we're only beginning to understand. The OR, Orchestrated Objective Reduction Theory, proposed by Roger Penrose and Stuart Hameroff, suggests that consciousness arises from quantum computations in neural microtubules, protein structures within neurons that might maintain quantum coherence long enough to influence brain function. While controversial, the theory at least attempts to bridge the gap between quantum mechanics and consciousness in a physically specific way. Whether or not quantum effects directly contribute to consciousness, the deeper point remains. Consciousness and time are intimately connected. Your sense of temporal flow depends on memory, attention, and the construction of narrative continuity. These are all functions of consciousness. Without consciousness, there's no one to experience time passing, no one to construct the story of change and becoming. This brings us back to the original question. If time is an illusion created by observers inside the universe, what does that say about the observers themselves? One possibility: consciousness is fundamental, as basic to reality as information, space, or energy. In this view, the universe isn't unconscious matter that somehow produces consciousness. The universe is fundamentally experiential, with consciousness woven into its fabric at every level. Individual minds are local concentrations of this cosmic awareness, temporary vortices in the field of universal consciousness. Another possibility: consciousness is emergent, but special, arising from information patterns complex enough to create self-modeling and reflexive awareness. We're not separate from the universe. We're the universe's way of knowing itself. Local regions where information has become so richly organized that subjective experience naturally emerges. Both views agree on this. The observer isn't an afterthought in the cosmic story. Consciousness isn't accidental. It's central to the whole picture, essential to understanding how the timeless quantum state gives rise to the experienced reality of temporal flow and change. Every spiritual tradition points to the same insight. Only the present moment is real. The past is memory. The future is imagination. Now is all there is. Physics confirms this, but with a twist. The now isn't a moving point traveling along a timeline. It's not a narrow slice separating past from future. The now is the entire structure of reality, the complete quantum state, containing all that is or ever will be. What changes is your position within this structure, not your temporal position, because time isn't fundamental, but your informational configuration, the pattern of correlations that defines your current state relative to other systems. As these correlations evolve, you experience movement through time. But the movement is within the timeless structure, not through some external temporal dimension. This eternal now isn't static or dead. It's infinitely dynamic, containing every possible change, every transformation, every moment of becoming. Change doesn't require time. Change is the nature of the relationships between systems, the way correlations form and dissolve and reform in endlessly creative patterns. From your perspective, embedded in these patterns, time appears to flow. You remember the past, anticipate the future, experience the present. But these experiences are all happening now, the only now, the eternal now, the timeless quantum state manifesting as your current moment of awareness. This resolves the paradox of flow. Time doesn't flow because there's no external dimension for it to flow through. But your experience flows. Consciousness moves through the structure of correlations, encountering different configurations sequentially, creating the feeling of progression from past to future. The block universe is real, but it's not frozen or deterministic in the way we usually imagine. It contains all possibilities, all potential futures, all paths through the configuration space of quantum correlations. Which path you experience depends on the choices you make, the observations you perform, the way your consciousness navigates the informational landscape. Free will becomes meaningful in this context, not as the ability to step outside causation and make uncaused choices that would be incoherent, but as the recognition that your consciousness participates in determining which correlations form, which possibilities actualize, which path through the timeless structure becomes your experience timeline. Every choice collapses possibilities, establishes new correlations, shapes the pattern of your trajectory through the eternal now. You're not passively experiencing a predetermined sequence. You're actively participating in creating the sequence through your observations, decisions, and actions. So where does this leave you, right here, as these words reach your awareness? You've traveled through Einstein's relativity, through quantum mechanics, through the dissolution of space and time into patterns of information. You've seen how the present moment contains everything, how memory constructs continuity, how consciousness navigates a timeless structure while experiencing flow. But understanding isn't the same as realizing. Knowing intellectually that time is an illusion doesn't automatically free you from psychological time, from regret about yesterday, anxiety about tomorrow, the constant mental narration that pulls awareness away from what's actually here. The shift happens when recognition moves from concept to direct experience, not through effort or practice, but through simply noticing what's true. Right now, in this moment, is there actually a past? Or are there just thoughts about the past arising now? Is there actually a future approaching? Or just mental simulations of possibilities happening now? Everything you've ever experienced has happened in the present. Everything you will ever experience will happen in the present. The present isn't a doorway you pass through on your way somewhere else. It's the entire room, the only room, the room that contains all rooms. This recognition doesn't require you to stop planning or remembering. Clock time remains useful. What falls away is identification with psychological time, the belief that fulfillment lies in some other moment than this one, that peace awaits in a future you haven't reached yet, or existed in a past you've lost. When that identification loosens, something extraordinary becomes available. The capacity to be fully here, fully alive, fully present to the richness of experience that's always been happening, but was obscured by the story of time. You don't achieve this. You notice it's already true. The timeless now isn't something you attain through meditation or spiritual practice. It's what remains when you stop overlaying experience with narratives about when and where and what comes next. The physicists were right. Time is an illusion, but not the kind of illusion that disappears when you understand it. The kind that transforms when you see through it, revealing the eternal, dynamic, infinitely creative present that was always here, masked by the convincing fiction of temporal flow. This is the universe's most intimate secret, hidden in plain sight. Every breath, every sensation, every moment of awareness is the timeless manifesting as time, the eternal expressing itself as sequence, the whole appearing as the unfolding story of your life. And now you know, not as abstract information, but as direct recognition. The past exists only as neural patterns firing now. The future exists only as imagination arising now. The present isn't a moment. It's everything, always, forever. Take one more breath and feel it. Not the concept, but the reality. This is it. This is all there is. And it's enough. It's everything. If this journey through the nature of time has brought you a moment of clarity or wonder, share it with someone who might find peace in these ideas. And if you're curious to explore more mysteries where science dissolves into stillness, you might enjoy our exploration of quantum manifestation, where intention meets the deepest structures of reality. Until then, rest in the eternal now. It's the only place you've ever been. It's the only place you've ever been.